Hello everyone, I'll just make sure I share my screen now. That's great. Okay, great. I'll be talking today about some macro and I'll combine consumer behavior patterns. And this project was completed with the help of my academic supervisor at City University, as well as my industry supervisors at Movement Strategies. In terms of the aim of the project, the main aim is to which footfall across different demographic groups can be predicted for event and non-event days using mobile and event listings data. The data was provided to me by Movement Strategies, and it was recorded by an O2 mobile sensor in the Bath Town Centre, which is located in the section as shown in the map. And it's a daily level footfall broken down by demographic groups, the results being for 2 gender groups and 10 age groups. The date range included most of 2019, which was used to train my models, and the first few months of 2020, which was used for model evaluation. First of all, I conducted some data analysis on both to understand which features in the data are important. Analysis are some patterns, especially for total footfall, where there is seasonal variation, with shown during the Christmas market, as little chart on the right-hand side, and as well as the weekday trend, where there's higher footfall on days. I further wanted to look down whether there's variation broken down by different demographic groups. And again, there is seasonal variation, with the most prevalent group during the summer being the 18 to 24, while the rest of the year is the 65 plus. And again, there's a weekday trend, with the Monday to Thursday, the most prevalent group is 65 plus, while Friday to Sunday is the 18 to 24. And what this analysis showed me is that it would be, first of all, important to include seasonal benchmarks for event comparison, and as well as including the day of the week and the month for my features in my model creation. I also wanted to explore how do the events are related to the footfall composition, and I chose 4 events for comparison. That's the Bath Festival weekend, the half marathon, the rugby games, and the Christmas market weekends. For the analysis, I mostly used population pyramids, with the red showing females and the blue showing the male proportions. And although when looking at the annual benchmark, I did see there are some small differences, when I was looking at the seasonal benchmarks, there were not that many variations, and that's possibly because of the sensor being located on the high street. So other people that were in the area for reasons such as shopping were also captured. In terms of the insights, one of them would be running, for example, seasonal promotions for maybe students that would be more likely to be in the area during particular times. Then it could be local promotions where maybe some restaurants or pubs around the stadium would be busier. And furthermore, it's also staff management, so local shops could hire more people during the busier time periods. This exploratory data analysis helped me further on build my predictive models. So it influenced my inputs, where I had footfall data and additional features, and as well as I included weather data, which has been previously shown to influence footfall. I chose 2 models, the XGBoost and the LSTM, which are both machine learning algorithms. In terms of the model implementation, firstly, I trained only on the 2019 data and I evaluated on 2020 data. And I further improved on that by improving on it and including the walk-forward validation. And what that does, it also takes 2020 data as it becomes available. So for example, if you want to predict the footfall on the 2nd of January 2020, you would take all the 2019 data and the 1st of January 2020. I further wanted to see if I could optimize the model. So this is the 1 day, 2 day, and 7 day lag. So that includes the previous footfall. With the outputs of the constraint is just the forecasted footfall across the demographic groups and the total. And to compare these 2 models, I used the root mean squared error. So in terms of the model results, which you can see in the table on the right corner. First of all, I had the initial models, which were trained only on 2019 data, and the LSTM had a better performance. But once I improved on it and I included the 2020 data, I could see that the XG boost with a 3-day lag window had the better performance. And in addition, having tested different windows, the LSTM 7-day lag also had an improvement of performance. And you can see that the little charts here just show how the two models perform in terms of predicting for the 2020 months. And what I saw that XG Boost had the better performance across all the different variations I saw, so across all demographic groups, weekday, weekends, and also for the two events which I looked at, half marathon and rugby. However, one of the main things I saw is that after the 15th of March, which is the week before the lockdown, the models do not predict as well, whereas before the prediction power was pretty good. And that's possibly due to the models not being accounting that behavior patterns have changed and the footfall patterns do not follow the same pattern as before. Is the XG Boost model. What showing how seasonality definitely affects the footfall patterns. And in terms of my insights and recommendations, first of all, is that businesses should consider that there is footfall during the COVID-19 crisis. So possibly different types of modeling would be more appropriate to model this. So that could be like scenario-based, such as assuming the same type of restrictions continue or different types of restrictions are in place. And also, most importantly, that including the weather and such as precipitation and humidity is very important, as we saw before that footfall is very highly seasonal. And that concludes my presentation.
Thank you.